Imagine a heavily loaded cargo ship creeping through a dark, narrow maritime corridor. A single mechanical failure here creates a choke point that freezes global trade. Hardware engineers have long understood this risk. Their foundational rule is multi-sourcing. Relying on a single proprietary capacitor or a specific chip from one factory is an unacceptable liability. For decades, software development operated outside this scrutiny. The raw materials used to build applications, open source code, local libraries, and standard compilers were largely static and predictable. The rise of the model-as-a-service economy altered the nature of software building materials. Model-as-a-service, or MaaS, allows developers to access massive artificial intelligence models over the internet instead of hosting them locally on their own hardware. Look at this architectural comparison. Traditional software design, on the left, was self-contained. Today's enterprise software, on the right, is increasingly hollowed out. It relies on a continuous pipeline of intelligence piped in from third-party APIs. Treating this dynamic external intelligence pipeline as if it were a static internal library creates a severe, unpriced vulnerability into the architecture. The companies providing the intelligence for these APIs are not neutral infrastructure utilities. They are active competitors and sovereign corporate entities that dictate the rules of passage. The enterprise supply chain no longer depends solely on the availability of code. It depends entirely on the availability and stability of a corporate relationship. A simple update to a vendor's terms of service or a sudden shift in their business model acts as an immediate supply chain disruption. Building an API-first product without an abstraction layer weaves a fatal choke point directly into an enterprise stack. The volatility in these provider relationships is forcing a strategic pivot, moving the priority from simple procurement to a mandate for architectural sovereignty. Consider ElevenLabs. They recently demonstrated how a shift in data policy causes silent disruption. In early 2025, they introduced a perpetual, irrevocable license to use customer data for their own model training. The chemistry of the component they provided had changed. For security-conscious enterprises, this breached their own product's integrity. When a vendor claims perpetual rights to the intelligence generated by your data, you merely lease the output. Companies were forced to rapidly rip and replace ElevenLabs to meet the safety specifications of their end users. OpenAI provides an example of a structural failure mode known as vertical cannibalization. Countless enterprises built specialized workflow agents and application wrappers using the GPT-4 infrastructure as their foundation. Then, OpenAI released Search GPT and Operator agents. The upstream intelligence provider began producing the exact bespoke products their enterprise clients were selling. When your upstream provider becomes your downstream competitor, your API dependency acts as a Trojan horse. The vendor can jump across any defensive moat built on top of their system. Building core enterprise value on a vendor's current temporary business model is an unacceptable architectural risk. Anthropic's recent actions highlight the direct geopolitical risk inherent in the AI stack. They began cutting off API access and extending data retention periods for startups they deemed too competitive. If Anthropic decides to enter a specific vertical, they can cite policy violations or competitive friction. Operational access is severed instantly. Highly efficient enterprise workflows built on these models exist solely at the pleasure of a third-party legal department. Operating under the constant threat of policy violations or competitive friction eliminates true enterprise autonomy. Securing the stack requires the first pillar of the sovereignty mandate, building systems that are completely model-agnostic by default. This requires a model router, or API gateway. This is a mandatory abstraction layer, a piece of software that separates the core business logic of an application from the specific large language model provider it relies on. An enterprise app routes a data stream through a central API gateway to a proprietary API. If the vendor changes terms, the enterprise flips a switch to bypass them. The gateway instantly reroutes traffic to a self-hosted open-source model, maintaining uptime without interruption. This establishes a definitive engineering rule. If swapping an underlying component requires rewriting the codebase, the software is a liability. Enforcing a strict abstraction layer neutralizes the threat of any single choke point in the supply chain. The second pillar of sovereignty focuses on procurement. Enterprise leaders must demand strict deployment requirements when buying from vendors. The first option is the full control mandate. Solutions must be deployed on-premise or within a virtual private cloud, a secure, isolated private cloud computing environment hosted within a public cloud infrastructure. Under this mandate, the model weights and the enterprise data must never leave the internal corporate perimeter. The alternative procurement requirement is configurable self-reliance for situations that utilize third-party systems. If a vendor uses a third-party model like GPT-4, the enterprise must have the option to provide their own API key. This ensures the enterprise dictates the exact model provider being used. The vendor is responsible for providing the foundational infrastructure plumbing, but the enterprise retains strict control over the water source. Possessing guaranteed, contractually bound escape hatches shifts the balance of power from the vendor back to the enterprise architect. The final pillar requires acknowledging and budgeting for the financial cost of architectural redundancy. Just as global manufacturers pay more for local factories to avoid shipping delays, software leaders must pay a sovereignty premium, the necessary capital expenditure to avoid supply chain paralysis. This involves specific investments, such as funding internal engineering teams to fine-tune and maintain open-source model alternatives. It requires a higher initial capital outlay to secure self-hosting rights from a vendor, bypassing the cheap, easy path of relying solely on public APIs. This sovereignty premium acts as a mandatory insurance policy, protecting the enterprise against a sudden vendor land grab. The core reality of the modern digital stack is simple. Structural dependence is an operational vulnerability. There is a permanent conflict of interest. AI giants will unequivocally prioritize the growth of their own ecosystems over your operational continuity. The resilient Chief Technology Officer views every API connection as a temporary convenience and every vendor as entirely replaceable. The ultimate goal of modern software architecture is to be fully exit-ready at a moment's notice. Achieving architectural sovereignty is the only way to guarantee steady business operations, regardless of which way the digital geopolitical winds blow.